Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today we would like to presentation about monitoring and sampling. Before of that, let me introduce our group member. First, Sheila, Luthfiah, Sinaga, Shafina, Mutia, Husna, Aditya, Suryalaksana, Sely, Kikiba, Putri, Aisyah, Rizta, Oktaviana, and Muhammad Arief, Solehuddin.
The topic of discussion is 1. Relationship between taking sample and monitoring program. 2. Kind of sampling method. 3. The factor that cause sampling error. 4. Preparation of sampling program. Relationship between taking sample and monitoring program. Sample is part of population. A population of organisms is total number of individuals and organisms that is in a place at a time currently. The actual target of the observation program is counting all individuals from a population appropriately. Problem with sampling: how to determine the right sample and can represent the population so that the result calculation on a sample can be used to approximate the true nature of the population. The sample taken are not representative so that the result obtained and used is not appropriate with what happened in the last fight. Incorrect conclusion can lead to adverse dedication. Sampling method recruitment. Observation must be reliable. Yes, the method will generate data which can represent or describe correctly about the nature of the population actually. Practical is the method of observation carried out sample, easy to do and not require equipment and method expensive, and wherever possible do not take long time.
Kind of sampling method. For number 1, absolute method. Close to the estimated population in the form of the number of individuals per unit land surface or insect habitat observed. Can be used for estimating population density in a particular observation area. The most absolute method has high accuracy, so it is better for ecological research and also risk losses. It costs money. A lot of energy is needed for the extraction of collected insect. For number 2, relative method. The number of population estimators is difficult to convert its land surface unit because of the large number of numbers that affect the estimator. Samples were obtained using insect traps, like traps or pitfall trap, and swing nets. Advantage is easier and more practical because insects are generally easier to find and count. Disadvantage: low statistical accuracy because it is influenced by environmental conditions around the tools and skills to observe the time of insect collection. For number 3, population index method. Count what insect leave behind, dropping, cocoons, nest, plant damage. Advantage is practical, especially useful in the decision making process and in estimating the damage to crop suffered. Disadvantage is very low accuracy because the population index collected is not a number. It cannot be used as an estimator of insect population figures with land surface area unit. The factors that cause sampling errors are A. The nature and skill of the observer, addressed by training observers in the field and providing guidebooks. B. Local environmental conditions, addressed by sampling adjust for pest behavior. C. The nature of the spatial distribution of insect is seen from the mean and standard deviation per unit sample. Mean equal to standard deviation is random. Mean greater than standard deviation is regular. Mean less than standard deviation is aggregate.
Preparation of sampling program. In preparing a complete sampling program in an area of observation, activities are needed to be carried out that aim to establish some criteria or provision on sampling. This provision include the determination of first sample unit, second sampling interval, third lots or sample size, fourth sampling design, and fifth sampling mechanics. First is sample unit. The sample unit is the smallest observation unit. In the unit is held measurement and calculation by observers of the individual insect that exists, and what is left behind by insect that become the object of observation or observation variables. Some of the observational variables that can be optioned from the sample unit can be the density or population of pests, natural enemy population, the intensity of damage, and etc. There are different types of sample units that are currently used in observational practice either for research program or for pest control decision making. Usually sample units are developed based on the biological properties of insects and learn from previous experience. Sample unit can be A. Unit ground surface area 1 times 1 meter, B. Ground volume unit, C. Plant parts such as clumps, stems, leaves, and leaf smelt, D. In the form of its own pest stadia often used for evaluation. In natural enemies such as the number of larvae of parasites or host larvae, etc.
Number two, sampling interval. Determination of sampling intervals. The sampling interval is the distance of one observation time to the time of the next observation on the same observation plot. Many factors need to be considered in determining of the observation interval include plant growth rate, observed insect life cycle, sampling purpose, weather factors, etc. For insects that have short cycles and high reproductive capacity, the observation interval must be short so as not to lose information from the field. Likewise, this condition applies to plant commodity that are sensitive to pest attacks such as cotton, and also to types of pests whose damage increase rapidly. Number three, lots or sample size. Determination of sample size. In sampling and observation programs, the determination of size, the samples or number of sample units that must be observed at each observation time greatly determines the quality of the observation results. Sample size is influenced by two main components, namely variance C2, which describes the distribution of sample data, and the cost of sampling consisting of power costs and sampling tools. In general, it can be said that the larger the sample size, the more trustworthy it can be. The price of population parameters, but if the sample size is large, then the cost of sample is also greater. Conversely, if the sample unit is too small, statistical analysis will produce decisions that have low accuracy so that the quality and usefulness of observation are doubtful.
For sampling design or sampling pattern, there are several patterns that can be used to establish which unit of the sample of the entire population should be observed, which is a member of the sample. The most ideal pattern is random sampling, then known first, layered random patterns, two, systematic sampling patterns, and the last one, purposive or predefined sampling patterns. Some of the sampling patterns that are often used are form, diagonal, zigzag, lacur. Five, sampling mechanics. Mechanical insect sampling is any technique of acquiring, collecting, and counting observed insect individual or material left behind by insect in a predetermined sampling unit. The sample mechanics that are often performed by our observer are direct observation in the field. Not all insects can be counted directly, so special equipment or tools are still needed that can be used to collect individual insects and then count the number.